Hello, my name is Lowell Vanderpool, and this channel is dedicated to IT students, IT professionals, and anyone who enjoys learning technical subjects. Now, I've personally been watching the single board computer ecosystem for a long time, and it's been fascinating. The innovation, the designs, the low cost, low power, all kinds of exciting options. Had recently had a need to build a low cost, low power Active Directory domain controller, and I decided to plunge in to the SBC world, and I chose the ZimaBoard. Although single board computers have been around a long time, it was really the Raspberry Pi that just exploded this whole arena of computing. It was very successful. It went with the ARM chip, was very low cost, very low power, was very hackable for developers, engineers, and students. Biggest drawback with the Raspberry Pi is it had a pretty steep learning curve to jump in and start using it. Now, the focus of most single board computers is keeping the cost low. So AMD has processors for single board computers. Intel, typically the Atom or the Celeron processors, although I've seen i7s on the single board. ARM is very popular, very powerful, low cost, low power, a front runner in the single board computer space. Now, a caution, anytime we're talking about these processors, in most cases, Windows is really not a great operating system for them. If you want to run a light version of Linux, excellent. There are two primary categories of engineers that are designing single board computers. There's the consumer engineers that are designing really radical, no rules, single board computers. They're focused on primarily low cost and flexibility. Now, there's another whole group of single board engineers, and they've been around a long time. That's the industrial engineers. They do them for embedded design products that need a computer. They build a single board and they embed this single board into some product. They're typically more bound by specific form factors. We'll take a look at those. Now, industrial single board computers are typically fanless, rugged, prices from $500 to $1,500, and I've seen them higher than that. They typically use AMD, Intel, ARM, depending on what they want to use them for. Most industrial single board computers use one of these single board form factors, from the FIMO ITX up to the EBX form factor. Now, for my particular project running Windows Server Core, I chose the ZimaBoard for a lot of reasons. Very low price, low cost, low power, preloaded with Debian Linux Lite, comes with Apache web server, Docker container, easily installed, sweet software development interface pre-built for this single board computer. It runs what is known as a CasaOS, which allows a very light web interface. You can install a variety of Docker applications built around the CasaOS. This operating system is clean. It's really easy to use. So the ZimaBoard comes with a CasaOS. It has Docker support, and you can install Docker applications. Now, it comes with support of many applications, but just keep in mind, this ZimaBoard fits in the palm of your hand. It generally is a 1 or 2 application appliance. So if you're thinking of running 10 different applications on it, you're probably not thinking carefully enough. Now, you don't have to leave the Casa operating system on the ZimaBoard. You can blow it away and put a variety of light Linux versions on it. This is ideal for pfSense, where I did a video on a cloud firewall using pfSense. This is perfect for that. If you wanted a software router like OpenWRT, this is excellent for this. Anytime you need a lightweight operating system, a dedicated application like a VPN server or maybe a streaming server, this is perfect for that. One of the features of ZimaBoard that really attracted me was it had a very, very well-developed firmware. Flexible boot options, has UEFI support, secure boot. It also supports CMS, which allows backward compatibility to the old BIOS and MBR partitioning styles. The ZimaBoard comes with a 32 gigabyte eMMC chip that acts like its hard drive. Now, it's preloaded with Debian and this CasaOS, but just keep in mind, you're not going to put a very large operating system on this 32-bit hard drive. In my case, I'm going to leave all of this preloaded software on this hard drive, but I'm going to use my firmware to boot to a secondary storage and boot up on the operating system, my choice. The CasaOS has a very nice, clean desktop GUI. So what makes this board so attractive? First, its features, its expandability, all the things that it can do. The fact that they've done a lot of the hard work in software development. They put Debian, they put Docker's web interface. You can just start putting cloud container apps on here already. It's just built in, ready to go. For an IT student, a newly hired IT professional, this is low cost. This is probably $210 to the door. At this cost level, this makes it very affordable even for the IT student. I'm going to use this for a domain controller, Windows 2016 Core, and have it my always-on DC controller. It's very low power, generates very little heat, and I can just put it in the corner of my studio and let it run. Now I've went ahead and removed 3 screws. I'm on my last screw here. Go ahead and pull this out. They did put thread lock on all the screws, which was a nice touch. You can tell engineers did this one. They're thinking through. Good design. This is a plastic. It's almost see-through. It's a plastic cover which protects the bottom of the circuit board. And then they also had a plastic spacer, which again protects the circuit board, lifts this plastic back up off the circuit board, protecting the back of this unit. It has 2 screws here that you have to take out in order to take out the heatsink, to remove this heatsink here. So I'm going to go ahead and do that. You can see there's a battery for NVRAM. And that's going to keep your settings that you set in your firmware. And then you can just simply lift this off. Just be easy with it. Don't get carried away. And basically you have the heatsink portion and the circuit board portion. Remember, keep these always on a static surface. Don't get crazy and start putting them on something that's non-static. I keep all my static bags so that I always have plenty of static bags. If I'm doing work with sensitive electronic equipment, I've got static bags to put the devices on it. This board is really well designed. And although I'm not an electrical engineer, I've done enough electronics to know when I see a well-designed, well-laid-out board. The soldering is excellent. Whoever manufactured this did an excellent job. So high quality on the board layout and the soldering. Now there are 3 models to this board. I purchased Intel Celeron, the N3450. It has 4 cores, 1 gigahertz base frequency, 2.2 burst, 2 megabyte L2 cache. It's got Intel's high-definition graphic 500 graphics processor with a clock frequency of 200 megahertz. It can burst up to 700 megahertz. It's got 8 gigs of memory. Onboard storage is 32 gigabits. Processor and the graphics is built into this Celeron chip. It does support virtualization, which is very, very nice. It does have the ability to stream 4K. I did do some streaming of 4K video with this on YouTube, and it got pretty hot, so I'm not so sure that I would want to stream 4K video very long on this unit. Here we have a series of voltage regulators right here, and if you'll notice on the heatsink, you have protruding pads that allow you to put thermal grease on strategic components, such as here we have a pad and a pad here that then will sit down on top of these memory chips, supposedly to help them cool. This is the pad that's for the graphics and CPU. You definitely want to make sure you have thermal grease on that. I did put thermal grease on all of these pads. These are your voltage regulators. I believe this is your inductors. These are your inductors that are part of this a step-down power supply from 12 volts to whatever voltage needed throughout the motherboard. Now on the outside, they don't have a power or a reset, but they did provide this breakout on the circuit board, and it allows you to get access to a power switch, a hard drive LED, a power LED, the reset switch. And so all you have to do is take something like this, which I usually have a couple spares. You can just cut and then trim back these wires and just gently solder in either momentary switches or LEDs into this interface on the board. Then you can hit power off, reset. You have your LEDs for your hard drives. So that's a nice touch. You'll have to purchase something like this. You can get them on Amazon. And you'll need to cut whatever length you want and then strip the wires back and then solder them in the holes. You have to be careful when you're soldering these. This is a pretty thick board, so you have to be very careful that you don't lift these pads when you're trying to put solder in. Over here, they've got a small area that you can add DC voltage, and they've added 3 extra connectors for 12 volts DC. This gives a little bit more power capacity to the board. If you're going to add storage, the best way to do it is solid state. Now these are SATA M.2s. They're not NVMEs. So I just bought a 2.5-inch adapter, and this one supports RAID. It does a RAID 0, RAID 1. This gives me the ability to take 2 250 gigabit SATA M.2 drives, stripe them, so that I get every bit of speed I can out of the SATA interface. Very low power. The internal supply here is more than capable of supplying power to a very low power storage configuration like this. Whereas a spindle drive, you're pushing it, whereas something like this, you can put a lot more capacity. You could put 500 gig in each one of these, or whatever you want to do. In my case, I'm just going to leverage a RAID 1 and a SATA interface. There's really no reason, although I could do a PCI Express using an NVMe hard drive. This NVMe hard drive is probably going to be overkill for this computational power on this board. One nice feature of the ZimaBoard is it comes with a PCI Express expansion connector. This is 2.0 times 4, so you can use it to add wireless, to add USB. You can add additional storage for NVMe or SATA, and you can add network cards. So this is really sweet for a single board. It has 2 SATA connectors with a proprietary power connector, which they do give you an adapter for. It also comes with dual 1 gigabit jacks. It also has USB 3.0, which is very nice. And it has a mini display port so that you can add an adapter and connect it up to VGA, DVI, and HDMI. Now here you can see that I've connected a flash drive. I've got a tiny wireless keyboard mouse dongle and a mini DisplayPort adapter that I bought from Amazon. All of that was recognized by the firmware and by Debian, so it was really easy plug and play. I didn't have to buy any kind of special hardware, and it easily recognized everything I plugged in. Now, your first order of business is to add additional storage. You can use SATA or you can use the PCI Express expansion, but you definitely need to add additional storage. You only have 32 gigabits of storage that comes with the ZimaBoard. As you add applications, you want to make sure that you configure those applications to be saved and stored on your secondary storage. You're going to quickly run out of hard drive space if you don't. So think about adding storage immediately, and then as you start playing with it, make sure that you save all your applications that you want to play with on the secondary storage. go ahead and boot up to our firmware. This is now our firmware logo, and here is your main firmware page. The menu items that you see on this firmware are very typical with a good firmware. Now under the advanced, it shows TPM support. I'm not sure exactly how that's implemented. Under USB, you can see that it's recognized your USB devices. You do have Pixie support. The SDIO configuration is where your 32-bit chip for your hard drive is. It's recognized as an SD card, which was very interesting. Under chipset, under South Cluster Preparation is where you can go see your SATA. And here you can see our SATA drives connected under port 1. Under security, you can set up a password, and you also have secure boot. Now under boot, it's very flexible. You can boot up in just about any way. You have CSM support, which is the old style BIOS. You have full UEFI, very flexible, very nice for today's operating environment. So you can set up many boot devices. Under save and exit, you have boot override, and you have things like restore defaults, default options. Back to advanced, you can see hardware monitoring. It does give you some view of voltages and temperatures. So that's nice. Here's some information on your CPU. Now here I've chosen to boot to my secondary storage, which has my Windows Server Core, and you can see there I go with my Windows Server Core boot. Go ahead and log on, and there you can see that's my 2016 Server Core, which I'm going to add AD to it, and it's going to be my Active Directory domain controller. Now let's reboot off of Debian Linux. This is the normal 32-bit hard drive that comes preloaded. And let's continue booting on up into the CasaOS. Now default, it boots into a desktop mode, and this is a very light version of Linux. Up at the top right, you can see you've got shutdown, you've got network access, your settings, things that you would normally expect on a Linux desktop. And you can drive around and see what you have there. They have some applications pre-installed, mostly games. Here's the drop-down menu for another way of accessing the applications. And again, you can see it's got a number of things pre-installed. Most you probably won't use. It does have a nice hard disk view, so you can look at your 32-bit eMMC hard drive, and here's my SATA hard drive for my Active Directory. Let's go ahead and launch the web interface, the Casa web interface. So I'm going to click on that, and it's going to launch a very light Apache web server, and it's going to give you the access to your Docker container apps. Now this is very interesting. It's got a very nice, elegant interface. Shows you some of your ZimaBoard features, status. This is pretty slick, pretty nice. This is very unusual for a single board computer. Here's your apps store that are pre-designed for this CasaOS. These are all containers, which is very interesting. Containers are usually not client applications. So this is an unusual way of developing containers. Normally they're back-end server modules of software. This is one container client application that I installed. It's a speed test. And you can just run it just like any other client application. But this is all running in a container, a Docker container, which is really innovative. I thought this was very interesting. Remember, most container Docker applications are on the back end of a server. They don't have a client interface. So there you have it, a quick drive through and a shutdown.